In this video I'm going to demonstrate the technique of integration by substitution. Now, when presented with an integral like this, we have two choices. We could expand this out a fourth power and then multiply through by the 2x term and get a great giant polynomial, fifth degree polynomial, and integrate each piece. That's one approach. That's the hard way. The alternative is to look for something here that we can replace with a simpler expression. Now, the key to this method is something in our working. If we find something and we take a derivative and that derivative is equal to or part of another thing in our expression, then it's pretty much a no-brainer that we should do substitution. I can see that the derivative of x squared plus 3 would be 2x, and 2x is sitting right here. So I'm going to let the x squared plus 3 be the thing I substitute. So I start over to the side by letting u equal x squared plus 3. Now, if it's not exactly clear why I'm doing this, it'll become clear as we go. The trick is, if there's something here, when we take its derivative, the derivative also appears. That's the clue that we should use this as our substitution. So let's do the derivative of this. Let's find du over dx. This would be 2x. That's it, the 2x is there. Now I need to not only replace this piece with the letter u, so here I go, there's the 2x. This bit is now u to the power 4, but I want to replace the dx with a du. So I'd better figure out what du actually is. What dx, I'm going to replace dx. So du divided by 2x would equal dx. Multiply the dx and divide it. So dx is actually du over 2x. Here we go, du over 2x. That's the part that made our life so much easier. So we have an integral of u to the fourth du, and that's a very straightforward integral. This would be u to the power 5 divided by the new power 5 plus our constant of integration. And when I write this with the substitution, x squared plus 3 to the power 5 all divided by 5 plus our constant, that's the quick easy way to do this integral. Recapping, we noticed that what we were given, something that we were given, had a derivative that appears here as well. That's the trick, that's the flag that says substitution is a good method. So we let this part equal u, take the derivative, rearrange to find the dx, and then we replace this bit with the letter u, still with power 4. We replace the dx with the 2u over 2x. These parts cancel. That's why we needed the derivative of this part to be sitting here as well. And then we have a very simple integral, u to the fourth, and there we have it. Don't forget, this one is an indefinite integral. There are no limits of integration, so we have to have our constant of integration here at the bottom. You definitely need to practice these, and these don't just happen with polynomial terms. You can have trig or exponential terms as well. As long as something here, the derivative of that thing, also appears, then you're ready for a substitution method.